Hello and welcome to video 8 for Math 123. In these next 4 videos we're going to be looking at probability and statistics. So first a couple definitions as we normally do here. So the definition of probability, it's the chance that something will occur So, a lot of times when we're talking about probability, we're talking about flipping a coin. So what's the chance that we get a heads? That would be 1/2. There's 2 possibilities, heads or tails. Heads is one of those possibilities. Or maybe we're rolling a fair die. There's 6 sides on it. What's the probability of rolling a 1? 1 out of 6. What's the probability of rolling a 2? 1 out of 6, etc., etc. And for the most part, if I don't mention it, assume that we're talking about fair coins and fair die as we do these probabilities. Obviously, if there's a weighted coin, the chances that it might come up heads would be less than 1/2. But for our purpose, for the purpose of praxis, we're always going to be talking about fair coins, fair die, etc. So to calculate probability, we have the following. The probability of E, some event happening, is the number of ways it can happen divided by the number of the ways it can or cannot happen. So again, if we're talking about flipping a coin, what's the chance that we get a heads? Well, what's the number of ways that it can happen? Only 1, we get a heads. What's the number of ways that it can or cannot happen? Well, it can be a heads or it can be a tails. Therefore, there's 2 ways there. So it would be 1/2 or 1/2. Here's a very important point. For probability, it will always be a value between 0 and 1, including 0 or 1. So if I have a 6-sided die, what's the probability that I get a 7? 0. There is no 7 on there. What's the probability of getting a 1, 2, 3, 4, 5, or 6? 100%, or a probability of 1. So sometimes you'll see them written as percents as well. What's the way of getting a heads? 1/2 or 50% if we convert it to a percent. All right. So we also have the idea of and or. And so let's assume we have 2 events. Let's call them A and B. And so for this example, let's assume that A is Tuesday and B is it's raining. So we have 2 possibilities we can talk about when we're talking about probability. And it's this idea of and or. So the probability of A or B, whenever we have this or, means add. So what's the probability that it's Tuesday or that it's rainy? Well, it's the probability that it's Tuesday added to the probability that it's raining. The other option is probability of A and B. And in this case, and means multiply. So it's going to be very important as you're doing these probability problems to figure out, is this an or problem, so I have to add the numbers, or is it an and problem where I have to multiply them? So, for example, am I going to do one? Yeah, we're going to do a bunch of examples here now, actually, so we'll see how these all kind of play out. And the thing with probabilities is at the start it can seem a bit overwhelming. Like, how am I going to do this? There's so many numbers, so many calculations. I got fractions. What I can tell you is the more of these you do, the easier that it gets. So I'm going to give you guys a bunch of examples here now. You're going to have some examples in the homework. We're going to be doing examples in class. If you still need more examples, you guys have the book. You can always go back and find examples there. But you want to do these, remember from the syllabus, I tell you guys what, don't do something until you get it right, do it until you can't get it wrong. So don't just do one probability problem like, oh, thank God I got the answer, I guess I know what I'm doing. No. Do 4 or 5 or 6, and if you still keep getting the right answer, then you probably know what you're doing. So the first example, and again, we're going to be talking about a fair die here. So what's the probability of rolling a 2 on a die? So, P of 2, probability of getting a 2. Well, on a 6-sided die, how many 2s are there? There's only 1. That's what goes in the numerator, the number of ways it can happen. How many different ways? Well, there's 1, 2, 3, 4, 5, or 6. So there's 6 potential numbers that could come up. So the answer for this would be 1/6. Second one, what's the probability? I'm going to do shorthand here now. So probability of rolling a 10 on a fair die. Well, again, I kind of gave you this example and gave you that or the answer already. But it's what? Well, there is no 10 on a 6-sided die. So this probability would be 0. You can't roll a 10 when you have only 1 through 6. Third example. What's the probability of rolling a 1 or a 2? So you have this 6-sided die, you roll it. What's the possibility that you get a 1? Or what's the probability that you get a 2? Well, I erased it, but or means what? Add. So this one is the probability that I get a 1 plus the probability that I get a 2. The probability I get a 1 is what? Well, 1/6. Probability I get a 2 is what? 1/6. Add them together because it's or. So add them, I get 2/6, which simplified is 1/3. That's between 0 and 1, so I can feel pretty good that, all right, it's between 0 and 1, so maybe I got this guy right if I did it correctly. All right, next example. This one gets a little more tricky. So, what's the probability of getting 2 1s on 2 dice tossed? 2 dice tossed at the same time. So, if you guys have ever been in the casinos, you've seen the craps table, they're throwing 2 dice. And what's the chance? This is called snake eyes, where one of the dice has a 1 on it and the other die has a 1. So it's what? It's the probability of getting a 1, let's call this the first die, and the probability of getting a 1 on the second die. Well, and means what? And means multiply. So probability of getting a 1 on the first die is 1/6. And means multiply. Probability of getting a 1 on the second die is also 1/6. So multiply these. There's a 1 out of 36 possibility, or a probability of 1 out of 36 of getting a 1 and a 1. Another way that you can do this, if you're taking the test and you forget, you just like blank out, like, oh my gosh, I can't remember, is this add them, is it subtract? So let's say, do I have this one here? Yeah, I have it later. So let me show you the table to start. What if we build a table here? So 1, 2, 3, 4, 5, 6. This is the first die. The second die over here, 1, 2, 3, 4, 5, 6. So if I have this table, so how many possibilities do I have? I have 1 and 1, 1 and 2, 1 and 3, etc. So I have what? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's 36 possibilities. So that's our denominator. Remember the number of ways it can or cannot happen. And I want what? I want 1 on the first die, 1 on the second die, which puts me in that box. That's the only one. It's the only option out of all these, so it's 1/36. So some of these later problems, it might be a little bit easier to use the table rather than trying to do the calculations from it. All right, next example, number 5. I'm going to leave the table here. What's the probability of getting a 1 on the first die and a 2 on the second? So again, if we do it mathematically, it's probability of 1 on the first die, and which is times probability of 2 on the second. So it's what? Probability of 1 on the first is still 1/6. Probability of 2 on the second die is still 1/6. So the answer is 1/36. And on our table, it would be what? 1 on the first die, 2 on the second die, so that guy there. So it's still the same probability of getting a 1 and a 1. All right, now, this is where it gets a little trickier, and the table may be a better option for us. Number 6 says, what's the probability of rolling a 3 and a 4? So in this situation, it does not tell me what? Which die it's on. So I actually have what? I have probability of a 3 on the first die, so I'll put a little 1 here, and a probability, and probability of 4 on the second die, so that's multiplication, and, or, so that's what? Plus probability of 4 on the first die and 3 on the second. So because it didn't specify it, it said what's probability of 3 on the first die and 4 on the second, then it would be like we've just been doing in the last two problems. But it didn't. It said probability of a 3 and a 4. So it's what? 3 on the first die, 4 on the second, or 4 on the first die, 3 on the second. So if I use my table, I get what? 3 on the first, 4 on the second, that's here, or 4 on the first, 3 on the second, that's there. So I have what? I actually have 2 out of 36, or 1 out of 18 if you simplify it. Let's do it mathematically. Probability of 3 on the first, 1 over 6. Probability of 4 on the second, 1 over 6. Multiply them together. Plus probability of 4 on the first, that's 1 out of 6. 3 on the second, 1 over 6. So I get what? 1 over 36 plus 1 over 36 is 2 over 36, which is the same that we had from using our table. And where the table could help you, so I'm going to erase that. If you have to pause or something and go back, that's fine. Another situation where the table could help you is if instead, so if we talk back about the craps table again, it's like, what's the probability that I get a 7? Well, that would be what? 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. Right? So if I add those up, 1 and 6 is 7, 2 and 5 is 7, 3 and 4 is 7, 4 and 3 is 7, 5 and 2, 6 and 1 is 7. So you get what? 1, 2, 3, 4, 5, 6. 6 out of 36 would be the probability if I roll 2 dice and get a total of 7. Okay there? Yeah, it looks like okay. So again, sometimes a table might be easier than trying to figure out all the combinations. So probability of 1 and a 6, plus probability of 2 and a 5, plus 3 and a 4, 4 and a 3. And you're doing the same thing, it's just that it's a lot less calculation, so maybe the table's a little bit easier. All right, and then lastly, the last problem we're going to look at here, number 7. And this is a typical praxis problem. So you should be comfortable doing this kind of problem we're going to do right now. And it says the following. There are 11 marbles in a jar. There's 4 red, 5 blue, and 2 white. John selects 1 marble so then we have the following 3 different possible questions here. First off, what is the probability that the marble is red? So, how many possibilities do we have? How many marbles are there? There's 11. So that's what goes in the denominator. Now, how many red marbles are in there to start with that we could pick out? There's 4 of them. So what's the probability that the marble is red? 4 out of 11. So B, what is the probability the marble is red or white? So, you're doing a problem on the exam. You see it's a probability. You see or, that should scream at you, this is an addition problem. I need to have some addition in here somewhere. So it's what? The probability the marble is red or white is the probability that it's red plus the probability that it's white. So probability is red is what? Well, we just did that, 4 out of 11. And what's the probability that it's white? Well, there's 2 white marbles in there, so it's 2 out of 11 that it could be white. So add these two together. It's nice because they have the same denominator, as you'll usually have in these probability problems. So we get what? 6 over 11. So there's a 6 out of 11 chance that it's red or white. Out of 11 probability, I suppose I should say. Chance, probability, the language is sort of interchangeable. All right, so C. Be careful with the wording on these problems as well. So C says, what is the probability the marble is not red? So, we have 2 ways we can go about this, and depending on how messy the problem is, sometimes one way is better than the other. So the probability it's not red means what? It's the probability that it's blue, or, which is plus, the probability that it's white. So the probability it's blue is what? 5 over the total number we have, 11. Probability it's white, 2 over 11. So there's a 7/11 probability that the marble we pick is not going to be red. The other way we could do it, we could do this. So let's call this way number 1. Way number 2 that we can do this, and this is why sometimes it might be better for the problem. Well, I guess the first way to say is, what's the probability of picking a marble? Well, 100%, right? He's going to reach in and pull one out. Probability it's not red is to say that he takes out that marble, but we're taking off the possibility that it's red. So another way to write this is the probability that it's not red is 1 minus the probability that it is red. So let's think about like our die again. What's the probability of getting a 1? 1 out of 6. What's the probability of not getting a 1? Well, 1, 100% probability, minus the probability of getting a 1, 1/6, or 5/6. So we can do the same thing here. The probability it's not red is 1, the total probability, minus the probability that it's red. We already, whoops, I erased it. We saw earlier, probability that it's red is 4 out of 11. So 1 is like 11 out of 11, minus 4 out of 11 gives us 7 out of 11. So again, sometimes maybe it's easier just do blue and white. But if you have a bigger sort of probability problem, it might take you a long time to calculate all the other possibilities. Maybe it's easier just to do 1 minus the probability that you know that you're trying to avoid. So that's it. That's sort of a introduction to probability. Come on back. We're going to talk a little bit about with replacement or without. Get into that a little bit. And then like multiple combinations. So right here, we were talking about 1 die or 1 coin or a jar of marbles. So we're going to look at other combination possibilities, and that will be in our next video.